Welcome to this deep dive, and thank you for joining us as we explore a fascinating academic review published in Electrical Power and Energy Systems. This deep dive will illuminate the multifaceted challenges and strategic pathways toward a truly sustainable energy supply, moving far beyond the traditional idea of just clean and affordable.
Mhm.
Today, we're diving into a massive body of work, a review that surveyed hundreds, literally hundreds, of academic papers to really unpack what it means to build an energy future that lasts. You might think it's just about swapping out fossil fuels for renewables, right? Simple switch. Well, prepare to have your assumptions challenged a bit. This review reveals a complex, interconnected web of economic, social, and environmental factors that, honestly, often fly under the radar in everyday conversations about green energy.
It's fascinating, isn't it? What this review really does is force us to broaden our perspective. It's a bit of a wake-up call, I think. The message is clear. Clean and affordable is simply not enough, not by a long shot. We have to grapple with the reality that global energy demands are still expanding, even as we pivot to renewables. That's key. And here's the kicker. Crucial resources needed for this transition. Think specific transition metals for batteries, vast amounts of water, even suitable sites for carbon storage, but they're actually concentrated in just a handful of countries. This geographic concentration, you see, creates these complex economic dependencies and, frankly, geopolitical chess games that significantly influence how fast or how slowly this transition can actually happen.
That's a crucial point to start with. So the authors of this review, they didn't just point out these problems, did they? They built a systematic framework. They pinpointed 10 critical energy transition issues, or ETIs as they call them, and then meticulously mapped how each one intersects with the United Nations Sustainable Development Goals, the SDGs. It's like they've given us this highly detailed roadmap of all the interconnected challenges.
Exactly, yeah. A roadmap is a good way to put it. And this really raises an important question for all of us. How do seemingly straightforward goals like SDG 7, affordable and clean energy, or SDG 13, climate action, suddenly become incredibly complicated when you look at their real-world implications? The review identifies these 10 ETIs as the dominant, pressing questions that dictate the actual pace and, crucially, the fairness of this global transition.
Okay, let's pick one ETI just to see how complex this gets. How about ETI 1? Prices, taxes, and subsidies. Seems straightforward, but
But it's not. When energy costs rise, who gets hit the hardest? The review clearly shows it's disproportionately low-income populations. That directly impacts SDG 1, poverty reduction, and SDG 3, good health and well-being. Obvious links there.
it doesn't stop there.
Not at all.
Ah,
These price increases can ripple right through the economy, penalizing industries, potentially slowing overall economic growth. That's SDG 8. So you see, it's not just an environmental issue. It's deeply socioeconomic. Very deeply.
okay, so that connects economics to the environment. What about ETI 6? Environmental protection itself. Moving away from fossil fuels is good, obviously, but are there hidden downsides to renewables?
Well, yes, and this is something the review really digs into. While it's clear that substituting fossil fuels limits global warming, the review lays bare a less discussed truth. Renewables themselves can have significant negative collateral impacts. Think about it. Solar PV energy, for example, has a large land intensity. We're talking potentially huge areas needed, which can affect habitats, agriculture, you name it.
Right, land use is a big one.
It is. And then consider wind and solar. They intensify the need for non-renewable mineral resources for batteries. And crucially, these batteries often need replacing multiple times during the lifespan of a solar PV system. That's a big resource drain. Even offshore wind turbines, out in the sea, they can increase water turbidity.
Turbidity, meaning the water gets cloudy.
Exactly, cloudy or murky, which can harm marine life, impacting SDG 14, life below water, and SDG 15, life on land. This whole dilemma, this trade-off, it's often kind of ignored in the literature, which tends, understandably maybe, to focus only on the positive impacts of renewables.
That's a really powerful point about those hidden environmental costs. And speaking of hidden complexities, the review also mentions hydrogen. It sounds promising, but you mentioned concerns.
Yes, hydrogen leakages into the atmosphere, while hydrogen itself isn't a direct greenhouse gas like CO2.
So what's the problem then?
The problem is, these leaks can actually reduce the atmosphere's natural capacity to break down other harmful greenhouse gases, especially methane. So, indirectly, it can undermine the very climate goals we're aiming for. It's a subtle, but potentially significant effect.
Wow, okay. Another unexpected link. Let's zoom in on another critical ETI. ETI 7, water stress and intensity. Water and energy. Maybe not the first connection people make.
Perhaps not, but water is absolutely crucial. For power generation, for fuel manufacturing, It's fundamental, and the review highlights that large-scale production of green hydrogen, the kind made with renewable electricity, while it's clean in terms of carbon emissions, it could significantly worsen water shortages, especially if you try to deploy it in regions already facing water stress.
So what's the solution there? Desalination.
Well, yes, but desalination itself needs a lot of energy, so you end up needing more energy just to produce the hydrogen fuel. It creates this complex, energy-intensive loop, and this ties directly into SDG 6, clean water and sanitation. Big implications.
That's a classic example of a trade-off, isn't it? You push for green energy, but then you create these new demands on another incredibly precious resource.
Yeah.
And about ETI 5, carbon capture and mitigation, CCUS. The idea of capturing carbon seems like a fix.
It's part of the potential toolkit, yes. The review suggests CCUS deployment will likely peak somewhere between 2030 and 2050. But it faces major techno-economic hurdles. Policy challenges, too. And one key issue is simply finding enough suitable geological storage capacity.
So we might not actually have enough places underground to safely store all the carbon we capture.
That's a real concern, yeah. The scale is immense.
And this raises questions about practicality. We hear a lot about nature-based solutions like planting trees. How do they compare?
They have a role, definitely. But the review notes their ability to actually abate carbon is pretty modest compared to our current emission rates. We can't just plant our way out of this.
Okay, and there's this other acronym, BECCS, bioenergy with CCUS.
Right, BECCS, combining bioenergy using plants for fuel with carbon capture. Theoretically, it can achieve negative emissions, actually pulling CO2 out of the atmosphere.
Sounds great. What's the catch?
The catch is scale. Again, large-scale BECCS, especially if it relies heavily on dedicated energy crops, could promote vast monocultures. Think huge areas growing just one type of plant for fuel. That has significant environmental impacts itself.
Like competing with food production.
Exactly. Competition for land, potential deforestation, serious trade-offs. This links back to ETI 6, environmental protection, and ETI 10, society, built environment, and mobility. It's not a simple magic bullet. Far from it.
No, clearly not. So what does this all mean for the stuff we already have? The existing power plants, refineries, ETI 3, fossil energy assets?
Yes. Carbon lock-in. Many capital-intensive industries have assets with incredibly long lifespans, decades sometimes. This creates carbon lock-in. Delaying climate action significantly increases the risk that these massive, expensive assets become stranded.
Stranded meaning worthless before their time.
Essentially, yes. Prematurely obsolete, financially damaging. And the review provides some really stark figures here that highlight the inequality. Wealthier nations, called Group 1, they hold about 35% of world oil and gas capacity. They're estimated to have the financial and technical capacity to cut nearly three-quarters, 74% of their production by 2030.
Yeah, three-quarters. And developing nations.
Developing economies with the lowest capacity, Group 5, holding about 13% of global capacity. The estimate is they'd only phase out about 14%.
Wow, 74% versus 14%? That's a massive difference.
It is. It underscores a deep, inherent inequality baked into the energy transition process itself.
That disparity is really eye-opening. And you mentioned cost earlier with hydrogen. Does the review give more concrete examples of these cost barriers?
It does. For instance, blue hydrogen, that's the one made from natural gas with carbon capture, is estimated to be roughly twice the price of the natural gas feedstock itself.
Twice the price. Okay. And green hydrogen?
Green hydrogen, made with renewables, 5 times the price of natural gas, especially once you factor in the costs of long-distance shipping, which is another challenge. This massive cost difference is a key barrier, a fundamental barrier to widespread adoption. And it feeds right back into ETI 1, prices, taxes, and subsidies. Makes the whole transition incredibly challenging financially for many parts of the world.
So, given all these hurdles, cost, resources, infrastructure inequality, how are different industries actually responding? Is everyone moving at the same pace?
Not at all. The review highlights quite different response lags among sectors. Perhaps surprisingly, industries like oil and gas, and also initiatives involving cross-sectors and cross-nations, seem to show relatively faster responses to the transition, adapting strategies.
Fast. Okay, who's lagging then?
Well, sectors like mining, heavy trucking, and aviation show much more delayed decarbonization efforts. It's definitely not a uniform shift.
Why the difference? Is it just harder for some sectors?
That's a big part of it. Industries with those capital-intensive, long turnaround assets, like mining, which ironically is critical for supplying the metals needed for batteries, they face bigger hurdles. And what's particularly striking, the review notes that the mining sector, despite being essential for renewables, shows, quote, irrelevant performance in decarbonization so far.
Irrelevant performance, why?
Part of the reason suggested is that it's somewhat shielded from criticisms, precisely because it provides these crucial, often bottleneck inputs for green tech. It's a complex dynamic, sort of double-edged sword.
That is complex. And policies must play a huge role in driving or hindering this.
Absolutely massive. The review points to examples like the U.S. Inflation Reduction Act, the IRA, huge tax provisions, grant programs, all designed to accelerate clean energy deployment.
But that has international ripple effects too, doesn't it?
It does. The review mentions potential trade protectionism concerns. Europe, for instance, is already thinking about its own response to the IRA, partly because of the subsidies and the local content requirements in the U.S. law. It really showcases the geopolitical interest tangled up in all this. It connects straight to ETI 10, society, built environment, and mobility. It's not just about green tech. It's about who leads the global clean energy economy.
So it's about economic competition as much as climate action.
You could definitely argue that. The review emphasizes that pushing the transition in industrial sectors needs a diverse policy mix. Carbon pricing, yes, but also renewable incentives, R&D funding, voluntary agreements, a whole suite of tools. And it highlights how policies like the IRA aim for shared economic growth, sure, but also very clearly for economic leadership. It's strategic. National interest plays a big role.
So bringing this all together, what does this mean for you, the listener, trying to make sense of our energy future?
This deep dive into the review in electrical power and energy systems has, I think, really shown that a sustainable energy supply isn't some simple switch you just flip. It's this incredibly complex, interconnected web. Technological, economic, social, environmental factors all tangled together. We've seen how resource concentration, water stress, the hidden costs of renewables, the huge challenge of transforming infrastructure, they're all critical pieces of the same giant global puzzle.
And this raises a crucial question, especially for policymakers, but really for all of us. As we try to get the best socioeconomic benefits at the least cost, how do we identify and really leverage local competitive advantages? There isn't one single path forward for everyone. The review stresses hydrogen's role as an energy carrier, potentially very important, but it even identifies the need for a carrier for the carrier, something like ammonia, maybe because transporting hydrogen itself safely and efficiently is still a major hurdle.
A carrier for the carrier.
Oh, wow.
Right. And look at the U.S. Department of Energy's clean hydrogen production standard. The target is incredibly ambitious. 4 kilograms of CO2 equivalent emissions per kilogram of hydrogen produced. That basically means near zero emissions from its production. Achieving that at scale, it underscores the massive ongoing effort needed to make this technology truly clean and economically viable. It's a monumental task.
It really is. It's clear that achieving a truly sustainable energy future requires us to look far beyond just the simple labels of clean and affordable. We need to embrace this multifaceted reality, understand the trade-offs, and approach it with open eyes. Thank you so much for walking us through this complex picture. Really insightful.
My pleasure. It's a critical conversation to be having.
Thank you for your participation.